Dear colleagues, let me present the results of our study, Software Engineering for Finite Element Analysis of Screw Fixation in Cortical bone. So, screws are the basic tools for internal fracture fixation. They may be used with plates, with nails, or alone to fix bone fragments. And from the fixation power of a screw depends a lot. Actually depends how fracture heals. So the finite element analysis is a fundamental research tool that is used by many researchers, and it can help us to assess the interaction between screws and bone tissue. Though we should admit that such calculations are time consuming and expensive, and also those big data sets to acquire this information and later processing needs quite a big amount of time and efforts. And for this purpose, some modern techniques like scripts may be used to optimize the process. So actually, the aim of our research was to compare the stainless steel and polyamide 12 screws, how they are fixed in cortical tissue, and to determine the ways of research process optimization by using custom scripts for collecting and analyzing the FEA study results. So we created a model of 3.5 millimeter screw and a segment of cortical bone of 5 millimeters thickness with a diameter of 40 millimeters that actually represented a part of diaphysis of femoral bone. So the screws was assigned with mechanical parameters for stainless steel 316L and polyamide 12. The input variables were the type of elements and their size, the materials, actual polyamide 12 and stainless steel, and the magnitude of applied load. The output variables were von Mises stress and displacements at the reference points. So a Python-based script was developed to make a dataset of obtained results with a further statistical analysis in MATLAB. The research was done according to this algorithm. So we start from creating a 3D model of screw and cortical layer. Then we created boundary conditions. We applied materials, forces, applied constraints. Actually, this bone segment was fixed in 3 directions. And then we made a mesh convergence sub-study to see which size and type of element better represents the real condition. So after solving, the data was collected with a Python-based script, and later it was processed in MATLAB. On this slide, you see the study made for stainless steel screws, and elements size were from 1% to 5% of total size of the model. Also, we compared 4 nodal and 10 nodal elements. And we see that different stress distribution was present. The von Mises stress was higher for polyamide 12 screws in superficial areas, and for stainless steel screws vice versa. It was high in deep areas. So for stainless steel screws, the stress ranged from 7 to 22 MPa in superficial areas and from 6 to 18.3 MPa in deep areas. For polyamide 12, stress ranged from 9.5 to 29 in superficial areas and from 3 to 9 in deep areas. So the difference in the stress was not statistically significant for stainless steel screws, but it was statistically significant for polyamide 12 screws. So this difference between superficial and deep areas. Assessing the results of our study, we should acknowledge that some researchers, like MacLeod et al. 2012, they suggested more simplified approach to replace actual contact between a bone and a screw by a virtual contact. They used springs, and they show that this approach is quite well validated and can be used for practical cases. But we think that perhaps if our aim is to assess interaction between a screw thread and the bone and the stress distribution from the screw to the bone, so the better and more accurate approach is to modeling thread itself. And some researchers, they show that actually physical parameters of a screw and a bone also have effects. So that may be the research question for our next study. And if we are talking about bigger constructs like plates and screws, perhaps simplified approach is better because it may save computational time. So using the developed Python script in our study, it significantly optimized the finite element analysis, VAC flow, and results of our study shows that polyamide 12 screws create more statistically significant stress difference between superficial and deep bone areas than stainless steel screws. So modeling of the thread has a potential to more accurately assess this interaction and stress distribution, but for bigger implants, for screws with for plates with many screws, perhaps better approach is virtual contact modeling. So the results of our study can be used for further biomechanical studies in this field, also for pre-operative planning in our clinical practice. Some references that were used for our studies are present on the slide. That's all for now. Thank you for your attention.